Hello everyone, today we want to talk about the basics of the MATLAB Simulink, and this is the MATLAB main window if you open the MATLAB. So if you go to the home and click on the Simulink, then you can open the Simulink environment. So this is a Simulink environment is initially is like this. So it's blank. So the model that you want to have should be modeled here. And here we have the run and a stop time for running of your model. So here we have the library, and from the library we have the blocks that you can move here for making your model and starting the simulation. Depend on which version of MATLAB or toolbox used, the, the, the library can be completely different. So when you're installing the MATLAB, if you also install the SimScap, so you will have this window. If you click on SimScap, here electrical, here you will have different components for modeling. For example, here is passive components, here is sources, all components are here. And here we have the specialized power system. If you click on that, we use this special power system because from here we want to reach to the power system model. So always we use the components that we have here. So here we have the passive components, power electronics. For example, if you click on power electronics, we have the diode, we have different components. So assume that we want to make one normal RC circuit, for example, or RL circuit. So first we need the passive components. The passive component that we need, for example, we need this one, just move it here. And it takes time. And we need, for example, a source. We can have one DC source. We can move it here. Then for connecting the wires, just connect like this and connect like this. Now, simply you can see we have the model that we want to run in simulation. Always when you use this SimScap special power system, make sure that you put this power GUI here. So here, if you double click on any component, then you will have the parameters. So here the branch type is RLC. For example, we need R, one resistance with 5 ohm, for example. Click OK. You can see it's changing. And if you press Ctrl R, it's rotating. So it will be like this. So we have DC voltage source and one resistor. This one is 100 volts and going here. So if you run, you can see the simulation is first compiling and then it will run for 10 seconds. But you cannot see any results here. The reason is that we don't have any measurements. So we need some measurements here. If you click on sensor and measurements, we have the current measurement and we have also other measurements, for example, RMS voltage measurement. Assume that here we need only the current measurement. We put here. The current measurement should be located in series. So we put it like series. Now we have the measurement, but here is the output. We should see the output in some scope. Just right here, scope. Here we can see we have a scope. If you move it here, a scope is for just showing the result. Is a measurement, and here is a circuit. And 10 seconds is so much. Maybe we can run it for 1 second. If we run, then if you double click on the scope, you can see that. So you can see here is 20. So 20 amp because it was 100 volt. It was 5 ohm. So 100 divided by 5 will be 20. If we want to have, for example, just remove this, back to library. If we want to have, for example, AC voltage source, Here is a voltage source that we can have. If you double click, here's the amplitude, phase, frequency, 50 Hz, for example, and click OK. Then if we run it, you can see we have AC waveform for a second. So we can see it's not AC, it's something like this. The reason is that we have very high sampling time. So you can see it's not clean. It's just we have one mirror here, the second one going here. It's not pure sinusoidal. So here, if you double click on the Power GUI, here we have the simulation type, continuous and discrete. So continuous, it's defining the step time automatically. Sometimes it's not correct, but if you click on the discrete, here you have made the sampling time. For example, something as a default, click OK and run it. Now we can see it's sinusoidal. And if, for example, we change this R to RLC, if we run it, then again we can see the current. So this is the simple way for simulating any circuit that you need. And you need only the measurements and components from here and a scope for running.